Assalamualaikum, my name is Muhammad Syahmi Daniel bin Khairul Anwar. Today I will discuss about introduction. Firstly, the motion of an object moving in a curved path is called curvilinear motion. To find the velocity and acceleration of particle undergoing curved motion, one only needs to know the position of the particle as a function of time. The waves formed in the seas and oceans are a result of gravitational force exerted on the water by the sun, the moon, and the earth. This gravitational pull causes the water waves to curve, thereby exhibiting curvilinear motion.
Next is basic theory. Curvilinear motion occurs when a particle moves along a curved path. Since this path is often described in 3 dimensions, which describe the most general case of motion for a particle. Vector analysis will be used to formulate the particle's position, velocity, and acceleration. The study of such motion involves the use of 2 coordinate system, which is planar motion and cylindrical motion. The planar motion and cylindrical components. In planar motion, the velocity and acceleration components of the particle are always tangential and normal to the fixed curve. The velocity is always tangential to the curve, and the acceleration can be broken up into both a tangential and normal component. With cylindrical coordinates, which are described as I and J, the motion is best described in polar form with components that resemble polar vectors. To investigate particle motion along a curved path is by using 3 coordinates system, which is rectangular components, normal and tangential components, and polar and cylindrical components. For example, we have the position of a particle P. So from this position of particle P, we can find the velocity by the derivation of particle P. And then we can find the acceleration by the derivation of velocity. The magnitude of the velocity of particle P is square root Vx squared plus Vy squared plus Vz squared. The magnitude of the acceleration of particle P is square root Ax squared plus Ay squared plus Az squared. Next is literature review. It is based on a spiral tube experiment. According to the impetus theory, when an object is set in motion, it gains a force in the direction of its movement, and this impetus gradually dissipates. An object set in motion on a curved path then gains a curvilinear impetus that dissipates over time. Thus, when asked to predict the path of a ball will continue to follow a curved path, in violation of Newton's law that a moving body with no force applied to it will move in a straight line. Kaiser found that an object predicted a straight path for water emerging from a curved tube, but a curved path for a ball coming out of the same curved tube.
Assalamualaikum, my name is Ahlam Azafar bin Azadin. My matrix number AA212238. I will continue this presentation about the case study of curvilinear motion. So for the question 1, the train engine at E has a speed of 20 meter per second and an acceleration of 14 meter per second squared, acting in the direction shown. The rate of increase in the train's speed and the radius of curvature of the path. So first of all, we must to draw the FDD first. After draw the FDD, the first step for this question is we must to determine the tangential and normal components for the acceleration. Acceleration for tangential component, which is 80 equals to 20 cos 75 equal to 5.176 meter per second square. And for normal component, which is AN, equal to 20 sin 75 equal to 19.319 meter per second square. And after we got the tangential and normal component, the second step is we must to calculate V from the tangential component of the acceleration. So the tangential component of acceleration is the rate of increase of the train speed. So 80 is equal to V naught equal to 5.18 meter per second square. And for the third step, calculate P, which is path, from the normal component of the acceleration. So the normal component of acceleration is AN equal to V square over P, and put the normal component into this formula, and we got 19.32 equal to 25 square over P, and we got the P, which is 32.35 meter. We move to question 2. At a given instant, the airplane has a speed of 30 meter per second square and an acceleration of 14 meter per second square acting in the direction shown. Determine the rate of increase in the plane's speed and the radius of curvature of the path. So for the first step, we must to draw or create the FBD first. The solution for this question is very easy, which is we must to find the normal and tangential component, which is normal component is AN equal to A sin 75 equal to 14 times 0.966 and equal to 13.52 meter per second square. And for tangential component, which is 80 equals to A cos 75 equals to 14 times 0.259 equal to 3.62 meter per second square. So after we got the normal component, we must to find the path by using the formula AN equals to V square over path, and put the information that have been calculated to the formula, and the formula should be path equals to 30 square over 13.52, and we got the answer for the path is 66.57 meter. For question 3, a boat travels around a circular path which is P equals to 50 meter at a speed that increases with time, which is V equals to 0.075 t square meter per second. The magnitudes of the boat's velocity and acceleration at the instant t equals to 10 seconds. First of all, we must draw the FBD, and after that we calculate the velocity at t equals to 10 seconds using V bracket t. So the velocity vector is V equals to V ut. So the magnitude is given by V equals to 0.075 t square meter per second, and we replace the t equals to 10 seconds, and the equation should be 0.075 times 10 square, and the answer is 7.5 meter per second. After that, we calculate the tangential component and the normal component of acceleration, and then we calculate the magnitude of the acceleration vector from the acceleration vector formula, which is A equals to AT UT equals to AN UN. We replace the AT equals to V naught and AN equals to V squared over B. To find the tangential component, we must to differentiate the V, which is 0.075 t squared, and the answer we got is 0.15 t. So replace t at equation of tangential component, and the equation should be AT equals to 0.15 t and equals to 0.15 times 10. The answer that we got is 1.5 meter per second square. To find the normal component, the formula for normal component is AN equals to V naught over P. So V is 7.5 meter per second and P is 50 meter. So put the value of these two things into the formula, and the answer that we got is 1.1125 meter per second square. To find the magnitude of the acceleration, based on the magnitude of the acceleration formula, which is A equals to square root AN square plus AT square. So put the value that had been calculated into the formula, and we got the answer for the magnitude of the acceleration is 1.89 meter per second square. For question 4, a jet plane travels along a vertical parabolic path defined by the equation y equals to 0.4 s squared. So at point A, the jet has a speed of 400 meter per second, which is increasing at the rate of 1.6 meter per second squared. The magnitude of the plane's acceleration when it is at point A. To solve this question, we must to draw the FBD first, and after that, the information of the tangential component of acceleration is the rate of increase of the plane's speed. So AT is equals to V naught, which is 1.6 meter per second square. After that, we calculate the radius of curvature of the path at A. So determine the radius of curvature at point A, which is x is equal to 10 km, and we differentiate the x, and we got the 0.8x. After that, we differentiate again the dy dx, which is d cos d square y over dx square, and you got the answer is 0.8. So when x is 10 km, so put the value of x into the equation of dy dx, and the answer we got is 8. So use the formula of the radius of curvature of the path, which is p, is equal to bracket 1 plus dy over dx square power of 3 over 2 over d square y over dx square, and put the value that have been calculated, which is dy dx is 8 and d square y over dx square is 0.8, and the answer is 955.06 km. After that, we calculate the normal component of acceleration. You use the formula of an equal to v square over p. So the v is 400 and the p is 655.06 times 10 power of 3, which is we have to change the kilometer to meter. So the answer that we got is 0.244 meter per second square. The last step is we determine the magnitude of the acceleration vector. We use the magnitude of the acceleration vector formula, which is a equals to square root at square plus an square. So put the value of at and an, and the answer we got is 1.618 meter per second square. For last question, a car travels along the road with a speed of v equals to 5s meter per second, where s in meters, p equals to 100 meter, and the question asks to find the magnitudes of the car's acceleration at s equals to 10 meter. To solve the last question for curvilinear motion is, first we must to draw the FBD first, and after that we calculate the velocity when s is 10 meter using v bracket s. So the velocity vector is v equals to v ut. The magnitude is given by v equals to 5s meter per second. So s is equal to 10 meter. So put the value of s into the equation of v, and the answer we got is 50 meter per second square. And after that, we calculate the tangential and normal components of acceleration, and then we calculate the magnitude of the acceleration vector. So the formula of the acceleration vector is a equals to at ut plus an un. So at is v naught, whether an is v square over p. For a tangential component, we must to differentiate the v, which the equation of v, and the equation of tangential component should be at equals to dv over ds times ds over dt, and ds over dt is v. So the equation should be at is equal to v times dv over ds. So v is 5s. So put the value of v into the equation of at, and the equation should be at equals to 5s over ds times v, and the answer we got is 5v. So v is 5s and s is equal to 10 meter, and the final answer for tangential component is at equals to 250 meter per second square. For normal component, the formula we use is an equals to v square over p. So s is 10 meter, so an equals to 50 square over 100, and we got 25 meter per second. For the magnitude of the acceleration, we use the formula of a equals to square root an square plus at square. After that, we put the value of an and at by using this formula, and the final answer for the magnitude of the acceleration is 251.25 meter per second square. So that's all from me. Thank you.
Next, I will discuss about discussion. The discussion that we can have through our report is that we can know what is curvilinear motion and how to solve problems, and we can also know how to use the formula for curvilinear motion. First of all, we need to know what is curvilinear motion. Curvilinear motion is a curved path is called a curved motion. For example, a stone is thrown into the air at an angle. Curved motion describes the motion of a moving particle that adheres to a known or fixed curve.
Assalamualaikum, my name is Abdul Yafiq Azwan bin Abdul Rahman and I will be taking over on the conclusion part. In conclusion, we have learned the theory of curvilinear motion and the application of them. We solved 5 different questions based on this topic and fully understand the solution on solving on each problem. We also found out that all the solutions have different variables such as velocity, 2 types of acceleration, which is normal acceleration and tangent acceleration, and displacement. Furthermore, all the formula in solving curvilinear problems are mostly derivatives from the other formula. For example, the formula acceleration is the derivative of velocity formula. Integration is required in this topic to obtain the instantaneous acceleration. Lastly, based on the questions and problems that we solve, we know that curvilinear motion occurs in almost everything in our daily life. These examples are cycling, turning of a car, motion of a snake, and airplanes making a U-turn. That's all for me, and this is the end of our group presentation. So thank you for listening and thank you.